Welcome to Entrepreneurship Vertical Startup Formation and Scalability. Today class we will discuss product life cycle with a suitable example. So far we discussed life cycle, different stages including validation, and we covered flexible methodology in the product life cycle. Now life cycle starts from design, end with the maintenance. We have a design, preferably two-dimensional drawing with the support of computer aided design. With that design, we go for simulation nowadays. After simulation, we are planning to evaluate with suitable mentors whether designed product is technically viable. Then we have a prototype. In the prototype, we have all the features of the product. With that prototype, we go for testing and validation. Different validation methods we covered. Validation immediately with the customer with the MVP, minimum viable product. With that minimum viable product, it's a technically viable. We go for mass production. So the prototype development after giving MVP feedback, we are going for correction. With that correction, with suitable information received from the customer, we go for product prototype design again. We are reconsidering the design. Sometime based on the customer feedback, we are reconsidering something extra in that conceptual design. Based on that final design we have, finally we have a proof of concept. You can compare with this our technology readiness level. Most of the startups failure even after 5th TRL level. The reason immediately we are not able to finalize the product due to customer feedback. We need to get customer feedback. With that customer feedback, we are planning to adjust our design, depends on the customer taste. Now once again, we will think about our product design development cycle definition, reconsidering based on the feedback received from the customer. Based on that, we have in the product life cycle redesigning, rethinking, reorientation, and rethink designing. Then we go for proof of concept. So start from design, then design developed, then prototype, finally testing and validation of the prototype, then getting feedback from the customer. We are changing something in the prototype. Once again, prototype design is changed. Finally, we have a proof of concept. This is the development. Let's test. This is mainly for SMEs, small medium enterprises. Now, proof of concept, validating the feasibility of an idea, whether it's suitable for next step of development of prototype. At that time, using simulation with suitable software, we are going for design modification. Then we have a conceptual design, translating idea into a tangible design. Through this mechanism, we have a brainstorming and creating blueprint using CAD software. Now I am going to give you a suitable example for conceptual design, particularly healthcare. We are going for implant, particularly in the leg. Before taking all those things, we need to design which part we are going to manufacturing that implant. For that implant going for manufacturing, We are designing with suitable information received from the customer with the support of doctor. Here, medical doctor giving information. So, engineer as well medical doctor together they are designing not only for implant, sometime for dental implant also. They are taking the information from the doctor. They are designing many things. With the designing using CAD software, we are going for simulation. In advanced level of simulation, we are connecting with the 3D printing. We have a prototype development. With that prototype development, this is design level. It's okay. If design is okay, we go for mass production and all. So support of artificial intelligence, computer aided design, we are getting feedback from immediately from the customer. We can reorient, redesign the at present condition one. So with the help of incubation center, technology readiness level, we can go in step by step. We can strengthen the technical visibility. Otherwise, the failure rate is more even after TRL level 6. So conceptual design, translating idea into design. Before going for prototype, we are getting information. So nowadays most of the medical field, that prototype, before prototype, immediately two-dimensional design drawing we are taking into 3D printer. Using 3D printer, we are taking a product here. So we can visualize with the dimensions, is it good? If a curve is involved in the design, after product development, with that suitable curve shall we go, or some modification where the problem arise. When you go for design and development with suitable simulation, if there is a sharp edge present in the medical implant, we go for prototyping, even scaling. With that sharp edging involved in that medical implant, because of loading, there is a immediate crack formation. The implant, after 3 2 years continuous working, because of stress, more loading on that particular point, there is a small crack formation, particularly in the neck. In order to avoid that, we are getting information, feedback from the patient as well doctor. Instead of sharp edges, they are converted into slope or curved one. With the curved one, we are going for manufacturing for mass production. Because of that, life of the implant is improved. While designing in the medical implant, we go for design in mechanical way. Similarly, we need to conclude biocompatibility. So medical implant involve mechanical design as well as our microbial biological compactness. For that, we have two different tests. One is called in vitro test, another one is called in vivo test. With that in vivo test and in vivo test and in vitro test, we are confirming biologically it's suitable. For that, we need some certification from the medical side. So design one side, mechanical side, another one side, biological side, both before going for complete product development, we need to analyze. So design software for mechanical strength, mechanical design. Here biological design, we need many things to adapt. So prototype development, building a working model of the product. Here we have a 3D printing assembly. A 3D printing with low cost, there are available for polymeric 3D printing. Product may be in the polymer plastics. For metal based 3D printing, cost wise very high. For before going for mass production, just for testing and validation, we are with the help of 3D printing with suitable polymeric material, we go for testing. So in the cycle operation, start from design, conceptual design, with that conceptual 2D design, using 3D printing machine, we can see the shape, size, compatibility, everything. For prototyping, same material with the same geometric dimensions, with the same features, with all the function we need to produce, but number is very less. At that time, 3D printing giving maximum advantage. With that maximum advantage of 3D printing, we are producing one or two product prototype level we are taking for immediate evaluation, getting a feedback from the mentor and society. We are giving what are the repeatability and the reproducibility of the product functioning. With that functioning, we go for mass production. Before going to SME, for small and medium enterprises, we need to complete minimum viable product level. Then the customer feedback is a good. We have a suitable customer, immediately buying customer. For that immediately buying customer, are we able to fulfill all their requirements? With that requirements, we can go for mass production. Before going for mass production, complete functional development as well evaluation required for prototype. Then only we can shift from TRL level 7 to TRL level 8. Now, the testing and evaluation. Sometimes stress involved, strain involved, stress and strain involved. For that, we have many mechanical testing. Mechanical testing include tensile testing, compression testing, fatigue testing, with the temperature involvement, what is the fatigue level, hardness how much, whether the surface resistance is good. These are the mechanical type of testing. For the information related to biocompatibility, we need, already I told what are in vitro, in vivo tests based on that biocompatibility. What are the advantage of this type of testing? While going for implant, after few days, immediate operation, there is post carrying treatment. After operation, post operative treatment, because of this biological microbial testing, giving a lesser amount of infection. Because of that, the patient care is very comfort and betterment. So patient care is good, the implant shelf life is improved, compactability also good, caring after post operation care is comparatively very less. Immediately patient go to their home. So these are the major advantage of biocompatibility testing, particularly for medical implant. Validation, before coming to the conclusion, we need to conclude whether this is conforming all the testing. With that, we go for scale with the TR level 9. With this, we will conclude this prototype development section. Next lecture class, with the suitable case study, we will complete the product life cycle. Thank you very much.